The dive light. The external dimensions of a dive light are no longer an indication of the strength of the light or the autonomy of the battery, and even very small dive lights can produce a very powerful light. As size is no longer a determining factor, we must look at the different features of a dive light in more detail. In the first place, a dive light must be suitable to take underwater. Watertight flashlights, both waterproof and water-resistant, are not suitable for night diving. To make a night dive safely, you need a main dive light of average strength and autonomy sufficient for a normal dive, between 30 minutes and an hour. A spare light is advisable, even though not a necessity. It should be small enough to put in your BC pocket or attached to the ring on the shoulder strap. A very useful light is a strobe, which can be attached to the ascent line a few meters, feet from the bottom. To have a powerful dive light with a long autonomy, you should choose a model with a separate battery pack. One of the essential features of a dive light is the type of handle. Small and medium-sized lights are usually held along the casing, while the larger ones have a carrying handle. It might be necessary to use both hands on the dive, so it is important that the dive light has a cord attached to it for safety, fitted with a toggle and even a carabine hook. So you have both hands free, you can use lights fitted to a helmet or the mask strap. However, in this case, it is impossible to look at another diver without blinding them. The switch can be mechanical or magnetic. The mechanical system has the disadvantage of having a hole through which the controls pass, a delicate point that is subject to leaks and electrogalvanic erosion. Instead, the magnetic system is more watertight. The switching occurs with the movement of a magnet outside the casing, near a small internal switch called a reed bulb, which is sensitive to magnetic fields. The crucial factor in the choice of a dive light is the strength of the light. Usually, the strength indicated by manufacturers, for example 20 watt, refers to the electricity absorbed, but this has little to do with the actual luminosity of the light. In fact, by changing the type of bulb, you can get more light even with a lower electrical power, as occurs with discharge lamps. To improve things, some companies have begun to indicate the strength in lumens, unit of luminous flux. This table lets us make a quick comparison between the absorbed power and the luminous flux generated. Other companies have begun to use the term lux, which expresses the quantity of luminous flux on a unit of surface area. It therefore depends on the distance from which the measurement is taken. A light strength equal to traditional 20 watt and 35 watt bulbs is more than sufficient for main dive lights, while 50 watts and 100 watts are strengths more suited to the dive lights used by guides or as lighting for videos. Instead, it is best to choose spare dive lights for their small size and limited strength, while favoring a reasonable autonomy. The main dive light should have a fairly wide beam, while the spare one should be narrower. Traditional light bulbs, the incandescent type, are made up of a filament enclosed in an empty glass bulb. As the current passes through the filament, it gets hot and becomes incandescent and gives off light. These bulbs have three substantial defects. Most of the electrical power absorbed is wasted in heat. The hot filament is particularly fragile. The light it emits, in respect to sunlight, is redder. To avoid this predominance of red, you can slightly increase the power at which the bulb functions. It is said to be overvolted. The light is whiter, but the bulb will be hotter and will not last as long. Another way of getting a whiter light is to use a halogenous lamp. Its structure is similar to that of a classic incandescent bulb, only that the bulb is filled with halogenous gas. Other types of bulbs are HID, which stands for High Intensity Discharge. Light is obtained without the use of a filament by electrifying the ions of xenon gas until an electric arc of great light intensity is produced. At an equal value of electrical strength absorbed, they are 6 times brighter than halogenous bulbs. They also have 5 times greater autonomy and emit a bluer light. In order to work, they need an electronic control unit that raises the tension of the batteries up to the 25,000 volts needed to start up the electric arc. They are not suitable to being repeatedly turned on and off, because the light is dim and yellowish as soon as it is switched on and then only gradually emits a brighter white light. Instead of a bulb, you can use LEDs, light-emitting diodes. These are efficient because they give off no heat, and the light they emit can also be very similar to that of sunlight. The safety switch is an accessory that is becoming more common on dive lights. With today's powerful and compact dive lights, there is the possibility that if a dive light gets switched on accidentally in a dive bag, the light itself could be damaged, as well as the other items it is in contact with. If the dive light doesn't have a safety switch, it is advisable to take out or disconnect the batteries, or remove the bulb. This precaution is also requested by many airline companies before dive lights are allowed on board.